so let's take a look at this next example. So some things probably jump out at you. Here are some of the important things that we can see here. We have one pivot variable. So one of our unknowns corresponds to a pivot. That's this guy. We have two free variables. There is a pivot in our augment. And when we write out our system, we see that b is equal to negative 2c and that 0 is equal to 1. So this system, from having a pivot in our augmented column, we can see is inconsistent. So there's no solutions. And this is because no matter how I choose A, which can be anything, B and C, there's just no getting over this 0 equals 1. So I would like you to notice, though, that if we look at a similar example, if we look at 0, 1, 2, 3, 0, 0, 0, 0, this again has one pivot variable, and it has two free variables. And now we can see that we are going to have infinitely many solutions. Indeed, we still have this first equation that b is equal to 3 minus 2c. We have a different constant now, and 0 is equal to 0. So if we write down the solution set, a can be anything, b is a function of the variable to the right, and c can be anything. So there are infinitely many solutions. We're going to just work with this a little bit more with the following example. So the claim is that no matter what we augment, a coefficient matrix with a pivot in every row will always be consistent. Okay, so there are a couple of cases here. So remember that we can have no more than the number of pivots is less than or equal to the number of columns, and the same thing is true for rows. So we have the maximum number of pivots in for our rows. Okay. So our first case is that we have that the number of pivots is equal to the number of columns. So in this case, we have a square matrix and a pivot in every row, and so a pivot in every column, and that means that our matrix looks like this in reduced row echelon form, the coefficient matrix. And we can see that every unknown here is going to be uniquely specified. So whatever we cared to augment, if we augmented star, 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 star 1, star 2, star 3, well, A is equal to star 1, B is equal to star 2, and C is equal to star 3. Okay, so this is a sort of a special case. What about case 2? In this case, we have that we have more columns than pivots. So what this implies is that we have a free variable, at least one. Okay, so we have more columns than pivots, so at least one of our variables is a free variable, because not all of our variables can be pivot variables. We don't have enough pivots. Okay, so the consequence of this is that every equation in our system is going to have the form comes from a pivot variable. Being written as a function of free variables. Okay. And so, because we can choose our free variables to be anything, and the free variables aren't restricted in any way, what this means is that all of these equations are going to be satisfiable. We'll have solutions. And indeed, in this case, we have that we have infinitely many solutions.